In this example, we would like to differentiate the function y equals f of x, which is equal to 2x to the 4 minus x to the 3 over 2 plus 1 over x. So to begin with, we should recall how we differentiate powers of x. So if we differentiate x to the n, all we do is bring this power down to the front and take 1 off the power. So to proceed to find dy by dx, all we need to do is differentiate each term in this algebraic expression. So the first thing we need to do is differentiate 2x to the 4, then take away the derivative of x to the 3 over 2, and then add to it the derivative of 1 over x. Now to help us with this question, we're going to recall that we can write 1 over x as x to the power of minus 1. That's just using your laws of indices. So what we need to do now is the derivative of 2x to the 4 can be written as 2 lots of the derivative of x to the 4. Remember, when we differentiate a constant times a function, we can just bring the constant out the front and differentiate the function. So the derivative of 2x to the 4 is just 2 times the derivative of x to the 4. Then take away the derivative of x to the 3 over 2, and finally add to it the derivative of x to the minus 1. So going through each one of these, to differentiate x to the 4, we see that n equals 4. So we bring the 4 down to the front and take 1 off the power, so we get 4 minus 1. So that gives us 4x cubed. And 2 lots of 4x cubed gives us 8x cubed. Then to differentiate x to the 3 over 2, our n is 3 over 2. So we bring the 3 over 2 down to the front, and then to the power becomes 3 over 2 minus 1, so that's a half. So we get minus 3 over 2 x to the half. And then finally x to the minus 1, our n is minus 1, so our minus 1 comes down the front. Then we get minus 1 minus 1, which is minus 2 for the power. So we get a minus x to the minus 2. Therefore, our dy by dx is simply 8x cubed minus 3 over 2 x to the half, which we can write as the square root of x, minus x to the minus 2, which we'll write as 1 over x squared.